Welcome to the Newton tutorial series. I'm Mike Cruz with AC-Tek, and in this tutorial I'm going to show you how to generate particle chains using Newton. So generating the chains is a little bit different than generating your normal material set. So the first thing to do is, if you look at your default library, one of these particle sets is the default particle set is called chain link. And if you look at that set, you can see there's only two clusters on that set, and they're two different vertical links. So what Newton will do is it's going to take these two clusters and it's going to just stack them as it generates one and then the other and then one and then the other. So your percent by weight in your clusters, that's irrelevant. It has no effect because it's just going to use one and then the next. Also, you'll look at the solids ratio. We've set the solids ratio to exactly 1 because that means that when I go in here and enter my bulk density, I can just use the true density of whatever this chain material is, rather than having to do a conversion, because the point of the bulk density is because we're generating usually a lot of material that has gaps and spaces, we have to use that bulk density. But when we're talking about a chain, well, there's only a finite number of links, and the true density is just easier to use than trying to calculate some sort of bulk density. It doesn't make sense with a chain. So you're going to want the solids ratio to be set to 1 for your chain link set. And then finally, you just have to check this little checkbox, which lets Newton know that this particle set is a chain particle set, and it should treat it as such. So then, on your material generation page, once you switch your group set to a particle set that is a chain link set, that has that checkbox checked, it's going to automatically set your generation method and change some of these settings here. So my, a typical 60 to 180, I could set block or do whatever I want. But as soon as I switch to a chain set, it forces my generation method to clusters. And if I try and change it, it keeps it there. So, because you have to have it set on clusters in order to do this. So then what you do next is you say, well, how many chain links do I want per chain? 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And how many total number of links do I want to generate? 66. So that's going to give me exactly 6 chains wide. And then, of course, when do I want to generate these chains? So the other settings you will do is you're going to position your chain. Now this shaded area that we usually use, that applies for your standard particle generation. But when we're talking about chain links, it's irrelevant, because all that we're going to do is we're going to start generating the chain at the bottom corner. If I'm looking at a top view here, if I'm looking at a top view, we're going to start generating the chain in this bottom left corner right here. And that means that if I was to, for example, manually change the size of this square, it's going to reposition my chain so that it starts there. So, but because we're not actually using this generation area, it's going to be easiest if you just leave this at the default, the default size of 1 by 1, and then it's just going to keep that at the corner. Of course, I could reposition it here as well. If I say, 0.5, it'll move my chain over into. So the whole point is you just want to line up that bottom left corner with wherever you want that first chain to be generated, and then it's going to generate across, just like that. So that was negative 0.1 and 1.5. And then the other settings, you set your link spacing and the chain spacing. So the link spacing is the distance between these two links on the same chain. So if I was to decrease this to 100, we're smashing those links together. So 150, we're stretching them out. Yep, 200, that's what it was. But you want to make sure, obviously, we can't start these clusters touching. We want to make sure there's a gap there between each of the chain. So if I was to say, 250, now we're generating the clusters partially inside each other. So if I was to run this simulation, I'd see that, actually technically there's too much overlap and it deletes the particles immediately. But if we said maybe 230, boom, they kind of bounce up like that. And that's not what we want to see. Boom. So you just want to make sure you position your chain so that there's a little bit of a gap there. 200. And then the chain spacing, obviously, well, how close do we want to put these particle chains to each other? So if I make this 300, I'm going to stretch it out 400 and so on. So finally, we can choose the direction that we want to generate these chains. By default, the default value of 0 right here in our chain direction means that if I look at this from a top view again, it means that we're going to generate the chains so that they hang vertically, they hang down, and they're going to be stacked in the x direction. So if I look at this, starting in my negative x direction, we stack these in the x direction. If I change it to 1, now they're still hanging vertically, but now we're stacking them in the y direction. So we still start at this corner, but now we're going to swap and move along this direction. If I change it to 2, now we're going to generate horizontal chains. So you can tell that these links are not set up properly because these are vertical links, and I'll show you that in a second. But the point is that now we're trying to generate the chain so that the chain hangs this way, and the chains are stacked in the x direction again. 3, 4, 5, 6. And if I change this to 3, well, now we're generating these chains so again they're stacked in the y direction. 1, 2, 3, 4, just like that. But it always starts in this bottommost corner, just like with the normal particle generation. So if I go to my chain link, so we started this particle set, or rather this default particle library has 4 links. There's the vertical links and the horizontal links. And the only difference is that the horizontal links we've taken and we've rotated. Because Newton doesn't actually pay attention to the shape of the cluster. Newton just says, well, I'm going to generate right at the center of the cluster. So you got to make sure that there's a little bit of you got to make sure there's some sort of hole so that you can link these chains together. So if I just change both of these vertical links to horizontal links, come on, horizontal, 2. Now it's going to generate them similar to this. And the fact that these two are interlinking right here, that's just an effect of this plot spacing. It has nothing to do with the actual way that the chains will be generated. So when I actually go in here, now that I've changed these to horizontal links and I generate them, well, now we say, oh, well, this isn't quite right still, and that's because they still need to be rotated about this vertical axis. So now if I go in here, well, actually, let's change this back to 2 because it'll work in this direction. See, if we're hanging chains in this direction, now they're interlinking properly because each link has the proper orientation. And so if I was to switch this back to the vertical direction, now again these are horizontal links, so they're not going to work with a chain direction of 1 or 2. But it does work for this one. And if I wanted to switch it so that it works for my swapping directions, I just need to take and rotate each of these about that z-axis. So if I go back to my particle library, my chain link leaves my horizontal 1 and horizontal 2. If I go into horizontal 1 and horizontal 2, and I go to my transform cluster window, and I can say, well, let's rotate that link by 90 degrees about the z-axis. And let's do the same for the other horizontal one. Rotate by 90 degrees. And that will automatically take effect in our particle set. We just need to go back in here and regenerate. Done. And now you can see that our chains are interlocking properly for these horizontal chains. And you'll notice that this corner generation, it generates that very first link at the exact center of gravity for that cluster. So it doesn't start it at the edge of the cluster or at the top of the cluster. It's right at the exact XYZ center of gravity. Oops. So even when I'm stacking my chains horizontally, I can still specify my link spacing. If I wanted to decrease this to 150, we're going to scrunch them up, or if I want to increase it to 300, now they're too far apart. 200 was what we were using. And I can still, of course, change my chain spacing and stack them differently here. 250, 300, and so forth. Now the last thing I want to note here is that these chains, these end links, are not actually connected to anything. If I start this simulation, these links are just going to fall through empty space. Well, a few of them were deleted because they were overlapping that bar. But they're not actually attached to anything. You have to put something that you will attach these chains to, a hook or a bar or whatever you want. So if I go back and change this to, go back to my chain link, switch these back to my original vertical links, vertical 1, vertical 2, and now I switch my change direction back to vertical. They're looking correct. Oh, this was 240. But now, as I mentioned before, like I showed you last time, if I try and switch and stack in the other direction, oh, these ones actually interconnect because the orientation of the links, the orientation of these vertical links will work with either chain direction 0 or 1. But when I switch to those horizontal links, I might have to reorient the position of this cluster to get it to work. So what if I wanted to switch which link was first? Because right now it's generating this, if I look at a top view, switch this back here and regenerate. We generate these in the proper direction. But what if accidentally the other one was on top? And I'm say, well, I want to switch the position. All you do is you go into your particle library, swap this, swap the position of these two links, go back and regenerate, and now it's started the other one generating first. Alternatively, if I really wanted to, I could leave the position the way it was, and I could actually manually go in and just rotate these links about that vertical axis. So the point is that Newton just looks at however this cluster happens to be oriented in your cluster creator. That's how it's going to generate it when it generates the clusters. So you have to make sure that you orient it and position it properly for whether you're doing a vertical or a horizontal chain. So let's go and regenerate this. And now if I go ahead and turn down my speed a little bit and turn this down. So now if I go ahead and say solver run, you can see as we start the simulation, those particles kind of drop into place. Let's turn our velocity scale down to 1.5, slow this down some more, and try that one more time. Boom, 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 boom. Trains drop into place. So then an example of what this looks like now. If you go to our website, this is the exact same video that we have in the examples section of our website. And basically, we've done some special meshing to mesh up these chains to make them look really nice. But this is basically what you would get. And there, if we color our chains by velocity, we can see how each of these links moves independently. They swing up and swing around. So that covers our chain particle chain generation. So just remember, solids ratio, set that to 1, and turn on your chain set. Make sure this bulk density now is just the true density of your material, and then set your link properties. So if you have any questions about the particle chains, go ahead and shoot us an email at info@actek.com, and we'll do our best to help you out. Thanks.